Mats here is the creator of Ruby. He has spent 27 years of his life without Ruby, and now spent 27 years with Ruby. So, and for those last 27 years, he has helped promote developer happiness, and he has been a big proponent for this Ruby 3x3 performance gain, and is going to talk to us a little bit about the functional future of Ruby. Take it away, Mats.
What's wrong with it? What's wrong with it? Okay. Before I prepare the slides, I have to tell you two things. The first, I'm suffering very bad jet lag. What the heck? No. What's wrong? It worked last time.
Can I help you, Captain?
No, I don't think so.
Okay.
It's in Japanese. Okay, I prepared. The second thing is last night I realized the keynote is 30 minutes. I thought it was 40 minutes. Okay, I'm in a kind of hurry. The functional or future will be. Open source community cannot stop, because we have to keep moving or we'll die. So that we have to move on to the future. So that our future is Ruby 3. We are currently planning to release Ruby 3.0 in December next year, 2020. And so that we are working on it. So that we are working on the Ruby 3 to fill the missing piece of the Ruby language. So that, for example, the performance or the addressing multi-cores or bigger team or projects. Then our future will be Ruby 3. And we are working on the performance and the new concurrency model and the static analysis. So let me talk about the static analysis first. Okay, these days the programming language, the static typing in pretty popular in programming languages, like say the recent language. For example, Rust or Go or Swift, they're all statically typed. As the project grows, the test becomes a burden. The test increases its size, and then test execution takes more time. But tests are not dry. The dry principle. So that we want to create the software that works, and then test is the another way to express the behavior, and when we ensure the correctness of the software by matching the different expression of the behavior. But it's kind of redundant. But we, the human beings, have not yet invented the way to create the correct software without tests. So we write tests anyway. But we want to be more productive, or we can live without the test burden. So that we want to reduce the burden of test writing. So that the other languages try, like PHP goes to the type hinting, the Python 3 goes to type annotations, and the JavaScript comes with the TypeScript. So that the more languages, like a scripting language, going to the static typing or gradual static typing. And then what should we do? The Ruby community do. adding type annotations like the others, like PHP or Python? I don't think so. I hate type annotation because it's not dry. We want other type hinting in the language because it's not needed. The plan for Ruby 3 statically analysis of code, the static type checking. The Ruby 3 comes with the static type checking components like this. The first one is the type definition syntax, the separate files. The type definition for libraries, and the type profiler, then static type checkers. The type definition syntax. A guy named Sotaro Matsumoto, yeah, he's not my relative, but he's a smart guy, and he wrote his PhD paper on the static type checking in Ruby language, and he abandoned the idea once. But this is his third try, and then separated files to describe types, argument types, return value types, class modules with the generic type and the interface, like this. This is kind of like a Ruby, but a different syntax because of the types. And we are not going to change the Ruby language, but we are going to add this kind of the type description file for libraries, or including standard libraries and and gems. And we are going to provide a tool to parse this RBI file. Okay, you can see these that tool, prototype of that tool in this this GitHub repository. Then we are going to provide the type definitions for the libraries, the standard libraries and gems. And we are not decided how to bundle this type annotation file to the gem file, but we are working with the Ruby gem team. Then the next component is the type profiler. The Yuskendo is working on this type profiler. He's there, and then the type profiler is the key component of the static analysis of the Ruby language version 3, and it comes with the abstract interpretation, which is virtually execute your program, your application in the abstract way with the type information. So that, for example, this is very small Ruby program, and you see the method foo is called with the argument 15, which is the integer. That means the foo is called with the integer, and the integer has the plus method with the integer argument. So that this is okay. But if you try to add the strings to A, which is type wrong, you can tell by information from the type annotation files from the standard library, so that you can have the error. This is very simple. So the type profiler works as the collecting type information of your application, and then detect type conflict of the existing type information of the standard library and gems. Then if the type checker works, so that you can generate the RBI file for your application. So the next time, so that you can use the RBI file to check your application. So the type profiler works as a level 1 type checker and the RBI generator. And but unfortunately, our type profiler is not yet that smart, so that you cannot detect, say, the generic types, or maybe some kind of the parameterized type, or maybe it's hard to distinguish the tuple, which is the uniformed class array, the uniformed class array and tuple, which is the class is of the element differs for each element. In that case, you can refine the generated RBI file so that your knowledge for application is required to refine that, so that you can refine by hand that generated RBI file. So that your RBI file is read before the generated one. So we may also provide the YAR to RBI file generator, so that you can use the type information from your YAR document. But this is only a plan, so that we are not working on it yet. Well, then the level 2 static type checkers. So that currently we have the 2, actually including the original RDL, so that we have 3 type checkers. The first one is Solbed from the Stripe, which is the sponsor of this conference. And then the Solbed is recently open sourced yesterday? I'm not sure. Yesterday. Yeah, yesterday open sourced. Currently, Solbed requires some kind of the DSL to annotate your code. But in the future, the Solbed start to read that RBI file, which I explained. The Steep is from the Sotaro Matsumoto, who is working on the RBI file parser. And then, those static type checker basically use theoretically use the RBI type definitions. Then they have different characteristics. The Solbed, you can see them from the GitHub. Is this correct URL? I'm not sure. And you can Google Solbed from Stripe. Okay, the Solbed type checker is pretty fast. It's totally written in C++, and even in the Ruby parser is written in C++. And then the type system is mostly nominal, and it supports type annotations, type annotation DSL. And we are working together. The core team and the Solbed team is working together. So we are working on the RBI support for Solbed. Steep is from this URL, and it's written in Ruby, and they're based on the structural typing. And since it's written in Ruby, you can play with some kind of the type checking systems, and it's more flexible. I expect that those two can have the healthy competition. So that those teams will have meeting together. So what will happen with those that static type analysis components? So that your ordinary Ruby programs will be statically type checked, and without any type annotation in your Ruby program, so that your existing Ruby program works as it is. You don't have to add any type declaration to your application. And if you refine type definition files, you will have the better checking, so that you more precise checking. And, wouldn't that be cool? I believe adding type annotations, type declaration to the language will hinder or change the characteristics of Ruby language. And actually, I love, and probably we love, the current characteristic, current language, so that we don't want to change the nature of the language, so that we want change the language. Instead, we are going to add these components for better checking in compile time. So we are working on it, and I think result is promising. So this is the static analysis. So the performance improvement. So no language can be fast enough. So people complain about the performance of every language, like Java. Some people complain about the Java performance, and then Ruby performance, of course, Python, PHP, Go, Rust, whatever. So that every language, can be complained about the performance. So and then we are working on improving performance since Ruby 2.0 has released. But the performance will be slightly improved in the past. Compared to the Ruby 2.3.4, the Ruby 2.60 runs, I don't know, some percent faster. And then that 100 is a Ruby 2.0. Compared to the 100, Ruby 2.6.0 runs 1.8, almost close to 1.8 times faster. Yeah, that's good, but we are trying to make it even faster. So that we need more performance, more traffic. We have to handle more traffic in the web applications. So the memory is the first bottleneck of the web application. In fact, so we have improved the GC performance. And for example, we introduced generational garbage collector in 2.1, then incremental garbage collector in 2.2, and transient heap in 2.6. And we are going to add the object compaction, which is Aaron Patterson is working on. We are going to release it and introduce it in 2.7 if everything goes well. The other bottlenecks are the CPU and the I/O. So to resolve the CPU bottleneck, we are working on JET compiler, just-in-time compiler, called MJET. MJET has introduced in Ruby 2.6, so that if you are using Ruby 2.6, so just add the .jet, the --jet, so that you can have the JET compiler for CPU-intensive task. For example, the CPU-intensive benchmark OptiCarrot runs 2.8 times faster, which is great compared to the Ruby 2.0. So it's almost close to three times faster. But for Rails app, MJet runs slower. Because most of the cases, CPU is not the bottleneck for web applications, and then memory bottlenecks comes first. And then in Rails is a huge application framework, so that we have too many methods. And then the applications, most of the cases, the web applications are I/O intensive. So we are working on the lighter compilation jet. Vladimir Makarov, who originally created the MJET, so they're also working on something named the MAIL. So I don't remember the acronyms, but something called MAIL, which is a lightweight JIT compiler. So that the MJET compiles. MJET generates the C programs from the Ruby code, then compile those C files by the GCC or clang, then dynamically load into the applications. That is a heavy process. And but with that MAIL, so that you can generate the unoptimized native code into the memory without invoking any compiler. So that this kind of the internal JET compiler runs much lighter and faster. The compilation time is faster. So we are going to have the lighter compilation and then we are going to have the 3-tier JET. I mean, some methods run in VM, right? Then some hot methods are compiled by the lightweight JET, and then very heavy CPU-intensive methods will be compiled by the optimized MJET. So those kind of the 3-tier JET will come into the Ruby 3. I don't think it will come into Ruby 3.0, but later in the Ruby 3. Okay, VM, MAIL, MJET. JET may not be useful for web applications, but the Ruby is used in many cases, like the batch project or some kind of the entertainment system. So in some cases, JET works pretty well. Maybe JIT maybe would be useful for research computing, like the faster number crunching. So in those areas, the Python is stronger and the Julia is coming. But with the JIT compiler, I hope Ruby will be competitive. Okay. The other way to improve the performance is the concurrency. The concurrency is hard. I read that in sets in the past. Remember, back in 90s, when I created Ruby, usually the computer has one CPU. So we don't have to care about the multi-cores in those days. So I lack knowledge and imagination about the threads. So in the real world, we have multi-core in our laptops, or virtually every computer has many cores right now. So under such situations, the threads are hard to use correctly and hard to use efficiently and hard to debug. So we need better abstraction of concurrency. So we need better abstraction. So we are going to add a new concurrency model, which is we call them GILs or isolates, or an outfiber or async whatever. So the GILs is provided for the CPU to resolve the CPU bottlenecks. The outfiber to resolve the CPU I/O bottlenecks. They are easy to use, easy to debug, and easy to perform. Go or Elixir use a single entity, like Go routing in Go or process in Elixir and Arlan. But we need. Oh, I'm sorry. But we have tons of history. Unlike Elixir, we cannot make every object immutable. Okay, from now on, all Ruby objects are immutable. All your web application will crash. No, we don't want that. We cannot re-implement everything. Like we implement Ruby virtual machine from top to bottom in, say, Ruby. That's not realistic. Some kind of the real world compromise. We have to add a two entity instead of one. But I'm not satisfied. We are not satisfied with those names, GILs and outfiber. So we need better names. So I don't know. Maybe isolate is the better name. And but Koichi, who is working on GILs, is not really like the name. The outfibers. Outfiber is the fiber or coroutine which context switches on the I/O operation, blocking I/O operation. So by using those things instead of threads, the context switch will be more far more lightweight. But the name fiber strongly indicates the coroutine, which is the context switch in the explicit way. So probably we might need better name. Okay, your opinions are welcome. Well, so the improvement improvements are inspired by functional programming languages because at the time I designed Ruby in 90s, I don't know very little about functional programming. So since they are different, functional programming languages are different from Ruby, so they are the source of the inspiration of the future Ruby. Static typing is the crucial part of the many functional programming language, and a concurrency model is part of the core of the Arlan and Elixir, and even more. For example, we are working on the numbered block parameters from Scala, Clojure, and Groovy, like this. Actually, I'm not fully satisfied with these ugly art signs. But 2.7 is coming in December, so that we have few more months. So yeah, we have to discuss and try out other ideas. Like other options can be at, or it, or square or something. Yeah, it comes from the Groovy and Kotlin. And yeah, this bracket is used by scheme language. And maybe the other things is better. Yeah, we're working on it. Pattern matching, not regular expression, but functional programming pattern matching. So this is some kind of the JSON matching example. The read JSON file, and if the JSON data matches the name, which name is Alice, and who has the children named Bob, and retrieve the age. So the age of the Alice's son, Bob, should be printed. Or, yeah, no, there's no Alice. This is quite straightforward. And otherwise, you have to write down the person name should be Alice, and the children should be children's name is 1. Then the first children's name is Bob, or something. So blah 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 blah, or something like that. Compared to these things, yeah, the pattern matching is pretty straightforward. So yeah, it's already merged into 2.7 in the trunk. So yeah, you can try out. Oops. Chaining or pipeline operator. Okay, 5 minutes. From F# and Elixir, okay, like this. Controversial. Instead of this, the pipeline operator. Okay, well, we have 5 more minutes, so we have to skip something. The pipeline operator is in F# is defined like this: let something something in the user level operator, and it as the primary argument, which is so for example, in the map function, the array, which is the primary argument, comes last at in F#. So the in pipeline operator in F# as the argument as the end of the parameters. Arguments, I mean. The pipeline operator in Elixir is different. It's implemented in the macro, but it as the primary argument as the first argument of the function call. Because in Elixir library, the most function takes its primary argument as the first argument of the function call. So the concept of the pipeline operator is to add primary argument to the call. So in case of the F#, it comes at the end, and in case of the Elixir, it comes at the top, the first argument. So if I would add the pipeline operator in Ruby, the primary argument to the call means add primary argument as the receiver of the method call, because of the most Ruby libraries takes its primary argument as the receiver. In Ruby, you can chain that with the usual dot operator, so that it's all out on the syntax. And yeah, but it has the different operator precedence. Like blocks, we have two expression for blocks, and the braces and the do and ends. And what's wrong? Okay. And yeah, by using this autonomous syntax, we have less parentheses. And I admit I'm not 100% confident about the syntax. Okay, note that it's before 2.7. It's okay to cancel or change. But I have to experiment. Okay, yeah, future options, and then keep it as it is, and or give up, or rename and design. Okay, renaming and design comes from, say, we don't call it pipeline. Instead, we call them chaining operator. Then change the operator, like, for example, yeah, arrow, 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 or something like that. Okay. As a side effect, from those experiments, we find out that we need to allow comments and new lines in the method chains. For example, like this. So but in current syntax, you cannot comment out the middle of the method chain, or you cannot add the new line in the method chain because of so the method chain will be cut and executed. But we are working on it to improve these things. So that now, near future, you can comment out the middle of the method chain, or you can put the new line in the method chains. Lights assignments is coming, maybe in the different syntax, different characters, but the right assignments is coming. So instead of writing the assignment at the top of the statement, you can add the assignment destination at the end of the expression. Right assignment is coming. As I said, we need to survive. You know, many people claim that Ruby has died or something like that. I'm sick of it, but at least we need to survive, to provide benefit to our users like you, and to sustain our lives. I'm working Ruby for full time, so that if Ruby dies, my family will die. That's problem. Yeah. So we have to survive. The Ruby have to survive to sustain our lives. We will keep moving forward to survive with you, the community input, so that to make you and we to make us happy, and to make world a better place. Thank you.
Thank you so much, Matt.
Yep.
That talk was fantastic. It's such a great thing to see the future of Ruby looking so bright, and definitely makes me a Jolly Roger. Here's a speaker gift for you from the team at EuRuKo. Thank you very much.
Thank you.